Hello everyone, and welcome to the video solution for Employee Database, a Mystery in 2 parts. Your assignment is a research project on employees of the corporation from the 1980s and 1990s. All that remains of the database of employees from the period are 6 CSV files. In this assignment, you will perform data modeling, data engineering, and data analysis. For data modeling, we will inspect our CSV files and sketch our entity relationship diagrams (ERD) of the tables using quickdatabasediagrams.com, and our output will be an image file of our ERD. For data engineering, we will use our ERD to create a table schema for each CSV file, and we will need to specify data types, primary keys, foreign keys, and other constraints. Once complete, we will import each of the CSV files to their corresponding tables, and our output will be a SQL file of our table schemas. And for data analysis, we will perform SQL queries to answer each of the 8 questions, with our output being a SQL file of our queries. Last is the optional bonus analysis, where we will create a Jupyter notebook to prove our hypothesis of fake data to confront our boss with. Now, starting with data modeling, we will attempt to create an ERD that looks roughly like this. To create this ERD, we will need to start by reviewing each of the CSV worksheets and open quickdatabasediagrams.com. We will start with the employees table and can see that we will have the fields employee number, birth date, first name, last name, gender, and hire date. Employee number will be an integer value and our primary key designated by int and pk. Birth date will be of date type. First name, last name, and gender will all be of varchar character type, and hire date will be of date type. Next, we will inspect the departments table and can see that we have the fields department number and department name. Department number will be a character value and our primary key, and the department name will be of character type as well. Now we will look at the department manager table and can see that we will have the fields department number, employee number, from date, and to date. Department number will be a character value, our primary key, and a foreign key to the departments table department number. The foreign key is designated by FK, a hyphen, and then the reference table dot the field, in this case departments dot department number. Employee number will be of integer type, and a foreign key to the employees table, employee number. Then from date and to date will be of date type. Now we will look at the department employee table and can see that we will have the fields employee number, department number, from date, and to date. Employee number will be an integer value, our primary key, and a foreign key to the employee table employee number. Department number will be a character type, also a primary key, and a foreign key to the departments table department number. Then from date and to date will be of date type. Next, we will inspect the titles table and can see that we will have the fields employee number, title, from date, and to date. Employee number will be an integer value, our primary key, and a foreign key to the employees table employee number. Then title will be a character type, from date will be a date type and also a primary key, and then to date will be of date type as well. Lastly, we will look at the salaries table and can see that we have the fields employee number, salary, from date, and to date. Employee number will be an integer type, our primary key, and a foreign key to the employees table employee number. Salary will be an integer value, then from date and to date will be of date type. Once we are done, we will export the final image as a PNG file. Now for data engineering, we will create the table schemas for each of our 6 CSV files, remembering to specify data types, primary keys, foreign keys, and other constraints. We will open pgadmin and connect to our PostgreSQL server. We will now create a database called employees by right-clicking and selecting Create Database. Next, we will open the Query tool by right-clicking on the employees database and selecting Query tool. And here we will enter and run our schema queries for our ERD one at a time. We will start with the employees table by typing create table employees, open parentheses, and then a new line for each of our fields. Employee number as an integer type and not null so that the field must be populated. Birth date as date type and not null first name, last name, and gender, each as character type and not null, and with values in the parentheses for their max length of the strings. Then hire date as date type and not null. And lastly, setting our primary key to employee number followed by a close parentheses and semicolon. Next, the departments table with fields department number and department name, both as character type and not null. And then setting our primary key to department number and setting our department name values to the unique constraint to make sure that the values stored in the column are unique across all rows in the table. Now for the department manager table with fields department number as character type and not null, employee number as integer and not null, from date and to date as date type and not null, then setting a foreign key to employee number referencing the employees table employee number, and another foreign key to department number referencing the department's table department number, and then a primary key to employee number and the department number. Next, we will create the department employee table with fields employee number as integer type and not null, department number as character and not null, from date and to date as date type and not null. Then setting a foreign key to employee number referencing the employee table employee number, and another foreign key to department number referencing the department's table department number, and then last a primary key to employee number and department number. Now we will create the titles table with fields employee number as integer and not null, title as character type and not null, from date and to date as date type and not null, but for only from date this time. Then setting a foreign key to employee number referencing the employees table employee number, and adding a primary key to employee number, title, and from date. Lastly, the salaries table with the fields employee number and salary as both integer types and not null, from date and to date as date type and not null, then setting a foreign key to employee number referencing the employees table employee number, and a primary key to employee number and from date. We will now run the SQL file to create each of the 6 tables. Next, we will import each CSV file into the corresponding SQL tables starting with departments. We will right-click Departments and select Import. Then we will select the Import button, select the correct file, set headers to yes, and the comma delimiter. Then click OK. If we were successful, we will see a green message box. We will then repeat the same process for our employees table and then each of our remaining tables. We need to be sure to import our department and employees tables first due to the foreign key assignments, or we will receive an error. Now we will save the file of our table schemas as a SQL file called schema.sql. Now that we have a complete database, we'll perform our data analysis to answer the questions from the instructions. We will open the Query tool by right-clicking on the Employees database and selecting Query tool. Question 1. List the following details of each employee: employee number, last name, first name, gender, salary. To do this, we will select those 5 fields preceded by their table aliases. Our from statement will be from employees set with an alias of EMP that we then will perform a left join with salaries aliased as SAL on employee number, and lastly ordered by employee number. Question 2. List the following details of employees who were hired in 1986. To do this, we will select all fields from our employees table where the hire date is between the strings 1986 01 01 and 1986 12 31. Question 3. List the manager of each department with department number, department name, the manager's employee number, last name, first name, starting and end employment dates. To do this, we will select those 7 fields preceded by their table aliases. Our from statement will be from department manager set with an alias of DM that we will then perform an inner join with departments aliased as D on department number, and another inner join with employees aliased as E on employee number. Question 4. List the department of each employee with employee number, last name, first name, and department name. To do this, we will select those 4 fields preceded by their table aliases. Our from statement will be from employees set with an alias of E that we will then perform an inner join with department employee aliased as DE on employee number, and then another inner join with departments aliased as D on department number. We will then order by employee number. Question 5. List all employees whose first name is Hercules and with the last name beginning with B. To do this, we will select all fields from our employees table where the first name is equal to Hercules and the last name is like B%, which stands for B followed by any number of characters. Question 6. List all employees in the sales department, including their employee number, last name, first name, and department name. To do this, we will select those 4 fields preceded by their table aliases. Our from statement will be from employees set with an alias of E that we will then perform an inner join with department employee aliased as DE on employee number, and then another inner join with departments aliased as D on department number. After the joins, we will select where department name is equal to sales and then order by employee number. Question 7. List all employees in the sales and development departments, including their employee number, last name, first name, and department name. To do this, we will select those 4 fields preceded by their table aliases. Our from statement will be from employees set with an alias of E that we will then perform an inner join with department employee aliased as DE on employee number. We will then perform another inner join with departments aliased as D on department number. After the joins, we will select where department name is in the list of sales or development and then ordered by employee number. Question 8. List the frequency count of employees' last names. In essence, how many employees share each last name. To do this, we will select last name and the count of last name from our employees table grouped by last name so that we can perform the count, and then ordered by the count of last name values. Now we will save this file of our queries as a SQL file called queries.sql. Now for the optional bonus section. As you examine the data with your queries, you suspect the dataset is fake. You guess that this is a test of your data engineering skills, and to prove this, we will take the following steps to generate a visualization of the data to confront your boss with. For this analysis, we will create a Jupyter notebook. According to our instructions, we will import our SQL database into Pandas data frames. Yes, we could import the CSVs instead, but after all, you are trying to prove your technical skills. We'll use the code that was provided for a SQL Alchemy engine to get started. We'll start with importing our dependencies, including pw from a config file where my PostgreSQL password is stored in the variable pw. Pandas for our data frames, matplotlib's pyplot for our planned plots, and SQL Alchemy's create engine to create our SQL database connection. Then we will create a simple pandas read SQL query. We will take the result of the query to import our employees table and then check the first few records with the head command. We will repeat this process for departments, salaries, department manager, and titles. For department manager and titles, we will use .fillinA pandas to date time 2050-12/31 to set the missing values to a future date of December 31st, 2050 to make them easily identifiable. To get a feel for our data, we will start by counting each title. We will notice a lot of staff and engineers with very few managers. Now we will merge our titles to our salaries table. We will then perform a check on the first few records with the head command. Next, we will create a subset data frame keeping only employee number, title, and salary. Then with our subset data frame, we will perform a group by on title and then calculating the mean rounded to 2 decimal places for our salary field denoted by our square brackets. Interestingly, all the averages fall between 48 and 52,000. Now we'll create a histogram to look at the distribution of these salaries, calling our dataframe.hist and setting columns equal to salary. we see that a majority appear to be between 40 and 50,000. Lastly, we'll create our bar chart of the average salary by title. To do this, we'll store our previous group by results in a new object called Employees Group by Title. We take our results to our boss, showing that the results seem illogical. Our boss then suggests that we look up our own employee ID number of 499942, so we'll go back to SQL. Now here we will run the select star from employees, where employee number is 499942. We find that our name is April Fool's Day. What a joker. And that concludes our video solution for homework assignment, Employee Database, a mystery in 2 parts.